We like presentations that create a tension, that create an intellectual tension between what you might believe and what's actually true. I like Richard's thought that we really need to think scientifically about what has happened and what is likely to happen. Here's a question for Richard Nehring. Richard, where are the errors in Chris Grabowski's analysis as you listen to him speak?
Well, I mentioned one to Chris. He talked about basically 6.5 years between the time of discovery and first production on these mega projects, which is, I think, we might argue about that, but I think that's a good average. But I think the more relevant characterization is between the time these mega projects are announced and the time of first production, and that's about a 4 to 5 year lag. And so essentially what we see in his analysis are all those projects which are announced, and thus we don't see anything, we see very few things beyond 2012, because that's 5 years from the future, and as far as these announcements are concerned. That's how much difference that will make is definitely something we could argue about at length, and we could probably go back and forth and have a very interesting discussion on that. There are some things that also fly under the radar, but which have a significant impact if you look at them, say, 5 years out. Like Shell announced earlier this year that they were going to introduce a pressure maintenance secondary recovery project in the Mars Ursa field in Mississippi Canyon area in the deep water Gulf of Mexico. This is the largest field offshore in the United States. The effect of that will only be to increase production from 160,000 barrels per day to 180,000 barrels per day initially, which would probably come under Chris's small projects, I believe. But they also announced with that it will increase the field life by 20 years. So that's maybe 5 years out or 7 years out, instead of looking at 20,000 barrels per day, you're looking at 100,000 barrels per day between what that field will be producing and what it would be producing if that project had not occurred. And there are some of these projects that fly under the radar, which over 5 to 10 years do have a significant effect. And I would say that those are probably the two areas I can think of immediately where we would differ.
A question for Jeremy. You showed a slide suggesting very little chance of significant improvement in offshore fields late in their life. Can you please discuss the case of Apache's takeover of the Forties field in the North Sea?
Well, I said, just looking back at the slide, I did say very low potential. I think it's great to see Apache going in, taking over Forties from BP and wringing a few extra barrels out. But whether it's going to have any real effect on the timing of peak oil or the shape of the curve after the peak, I would rather doubt. Yes, they've made a big investment, and they've extended the life of the field probably by 10, 15 years, and they may wring an extra few million barrels of oil out, but I don't think it's significant in terms of the overall problem that we're talking about.
Do the national oil companies have the same incentive, a question for both of you, and the same technologies that the international oil companies would have? Do they have the same motivation, desire, and commitment to reserves growth?
Yes, I think they do. They didn't have in the past, but I think they've, if you look at the more active national oil companies, if you look at Saudi Aramco, if you look at ADNOC, if you look at NIOC, I think they are doing great things in their reservoirs. The Iranians have come from way behind. Post the revolution, they were left with virtually no technological input from the West at all. They've gone back and invented everything from scratch, but they're doing the same sort of things in their oil fields now that the West are doing. Their motivation for doing it, I think is very strong. But the significant difference, and maybe I didn't get that across in my talk, is that when they calculate reserves at the start of development of a field, they don't do it in the same way that an American company would do for a field in America. So the reserves growth potential, which is certainly there, is built into their initial estimates. And there isn't then the same potential for increasing reserves later in field life. This is the essential difference. If you're calculating reserves as is done under US SEC rules, of course your reserves will grow with time. They can't do anything. It's almost impossible for them to decrease. But in real life, if you calculate your reserves on a technical basis, as I showed in my fourth slide, I think, the reserves are just as likely to go up as to go down. There isn't overall necessarily reserves growth at all. This is the real difference. It's nothing to do with with national oil companies and IOCs. It's just a basic difference in the way people calculate numbers.
Yeah, this is, I alluded to this somewhat in my remarks. If one would use the SPE definitions, which you normally say, which say a lot of the national oil companies do adhere to, that allows you to have basically proved and probable reserves. It allows you to have both developed and undeveloped reserves. Maybe because I'm what I say a recovery growth imperialist, use proved developed reserves, which is essentially the SEC criterion. And if you do that, you get a lot of growth. If you use the SPE 2P and with both developed and undeveloped, you don't get much recovery growth. But basically, you're just really, the argument there just becomes an argument on how you allocate this to what categories, and it's not, I think the proved developed reserves, the SEC one, is the relevant one to use, because I think, as Chris rightly emphasized, is that what really matters here are flows, not reserves, and the only reserves that provide flows are proved developed reserves, and until they are proven and developed, they don't do us any good. And that's why I like to begin that, and if you begin with that, then you see a lot of growth. If you begin with the much broader definition of reserves, you don't see that growth.
Can I just come back for 1 second?
Absolutely.
I think the basic problem here is for people who don't make a professional practice of calculating reserves. When you drill your first well in a field, if you have a field with one well in it, the field looks homogeneous. You've no real way, unless you've got some very, very clever geologists and geophysicists around you, you've no real way of determining that the properties that you see in your well don't apply throughout your reservoir. So it looks a simple reservoir. You drill 2 wells, you've now got twice as much data, and you can start to see differences. As you drill more and more wells, the field is likely to look more complex. And if it looks more complex than you thought originally, there's no reason at all why the recovery efficiency you expect to achieve has to increase. It may decrease. So the whole concept of reserves growth, which Richard talks about, derives only from the way in which you calculate reserves initially. If you look at the whole field, make an estimate of how that field is going to behave over its life, there's no reason why reserves should grow at all.
I have 24 wonderful questions up here, and we're not going to get to all of them, but let's do a couple of quick ones. Richard, if your analysis is correct for recovery growth, are you shorting oil now?
Excuse me?
If your analysis is correct for recovery growth, are you shorting oil now?
No, I'm not, because it's, as I indicated, I think it's a very long, drawn-out process to achieve these, and there are definitely constraints on how fast you can develop these, and I've been I guess I've been investing for the past 5 years and done very well on the assumption that oil and gas prices will increase.
Okay. So you are a peakist of some kind or another. We may need a biologist to define peakist later in the day here. One more quick question. Jeremy, how much more effort and energy is required to produce this extra oil from fields to enhance the recovery factor? How rapidly does the energy return on the oil fall typically as you would do this process?
I don't think there's a single answer to that. I mean, it depends. Some fields, the energy, the output, the return on your energy input can be quite sudden. If you've got a very incompressible oil in a field with virtually no water drive, and you inject water, for every barrel of water you put in, you'll get more or less instantaneously a barrel of oil out. But if you're looking at a tertiary recovery process, where perhaps you're injecting immiscible gas, it may take many years from the time you inject that gas to the time you will actually see any significant additional recovery. So there isn't a single answer to that question.
On thermal oil projects, like, for example, the heavy oil fields in the San Joaquin, California, in effect, you use about 1 barrel of oil or its energy equivalent for about 4 barrels they produce. And in really extra in situ, extra heavy oil development or bitumen development in Canada, that could go up to about 1 barrel for every 3 barrels being produced, depending on the process you use. There are some processes, for example, the one they have a pilot project on, which they figure maybe the energy use will only go down to about 1 barrel for every 8 or 10 barrels produced. And so it varies a lot from process to process, even from the same type of resource.
There's a wonderful question here about Eugene Island, which is a famous example, but both speakers will be here all day. Feel free to ask some additional questions. Maybe we can have one more round of applause for them. Thank you so much.